Hey everyone, welcome to my channel Nihal's Lab Notes. In this video, we are going to see character encodings to avoid Unicode decode errors when loading CSV files. So we are going to be working with a different character encoding. So let's get started. So this is the dataset that we are going to use Kickstarter project from Kaggle. We are going to download it here. I will put the link of this datasets in the description below. You can see here the context of this datasets, all about this dataset. And here you can see that contain 16 columns and 2 files of CSV file. Now let's see what are encodings. Character encodings are specific sets of rules for mapping from raw binary byte strings 0 and 1 to characters that make up human readable text like hi. Character encoding mismatches are less common today than they used to be, but it's definitely still a problem. There are lots of different character encodings, but the main one you need to know is UTF-8. Let's get our environment set up. The first thing we'll need to do is load in the libraries we'll be using, not our data set through. We will get it later. So let's first of all import pandas as PD, then import numpy np. And this library imports parsets, normalizer. This will be a helpful character encoding model. Now let's set seed for reproducibility as always. So np.random seed of 0. Let's execute this. Okay. It was pretty hard to deal with encodings in Python 2, but thankfully in Python 3 it's a lot simpler. There are two main data types you will encounter when working. So in Python 3, let's start with a string. Let's say s1 equal to this is euro symbol. Let's just check to see what data type is it. So type of this S1, sorry here, type, it's a string as there. The other data is the bytes data type, which is a sequence of integers. You can convert a string into bytes by specifying which encoding it is. So let's do this. So let's name it with s second 2. Let's say s1 dot encode. Let's specify UTF-8 errors replace. And here let's check for, sorry, this not like this. Then let's say type of this is 2. And as you see here, we have the type of this is bytes. So here we have already convert a string into a bytes. Now let's take a look at what the bytes look like. So let's just print s2. As you see here, if you look at a bytes object, you will see that it has a B in front of it and then maybe some text after. That's because bytes are printed out as if they were characters encoding in ASCII. Okay. Back to ASCII. ASCII is an older character encoding that doesn't really work for writing any language other than English. Your symbol has been replaced with some mojibake that looks like this when it's printed as if it were an ASCII string. So we have another example of a mojibake with blue. You may also end up with an unknown characters. Now let's convert this back to UTF-8. So let's just print S2 dots decode and use UTF-8 here. So as you see here, when we convert our bytes back to a string with the correct encoding, we can see that our text is all there correctly, which is great here. You can see the error symbol is appeared. Now let's try to decode our bytes with the ASCII encoding. So let's print S2 dots decode with using ASCII. So I can say here that it will generate an error, as you see here. So we can also run into trouble if we try to use this, the wrong encoding to map from string to bytes. Like I said earlier, strings are UTF-8 by default in Python 3. So if we try to treat them like they were in another encoding, we'll create problems. As you see here, we have an error. Unicode decode error. ASCII code cannot decode bytes. This in position ordinal. You can see an error. Now what we have to start with a string here, then encode it to a different encoding, replacing characters that raise errors as you see, then convert it back to UTF-8. So let's just execute it. So this is the euro symbol. We have lost the original underlying byte string. It's been replaced with the underlying byte string for the unknown character, as you see here. So we can say that is bad, and we want to avoid doing it. The first step is reading in files with encoding problems. Most files you will encounter will probably be encoded with UTF-8. This is what Python expects by default. So most of the time you won't run into problems. However, sometimes you will get an error like this. We'll try, and this is the error. You can see here UTF-8 code cannot decode by in position invalid start by. Now let's look at the first 10,000 bytes to guess the character encoding. To do this, just work with word and open. Take the path, then we need to add RB, I think, yeah. As raw data, points results equal to char sets. Let's normalizer detects raw data. Let's read and let's print it to see just the header. So let's just say prints the results. And you can see here the encoding is just Windows on language and confidence. So we can say here that datasets equal to ed.read.csv file and the path. Then we need also the encoding. So for the encoding, I'm going to say Windows 1252. Things gonna work. Yeah. 52, I think. Wait, encoding. Let's look just the header. So datasets dot add. As you see here, here's the datasets. So it looks like the chart that normalized was right here, 1252 in general Windows 1252. Okay, so the file reads and with no problem, although we do get a warning about this data type. Now we are going to see the next step is saving your files with UTF-8 encoding. So let's see how to save your file or your files with UTF-8 encoding. Select here Markdown, and so finally in this step, once you've gone through all the trouble of getting your file into UTF-8, you will probably want to keep it that way. So the easiest way to do that is to save your files with UTF-8 encoding. The good news is since UTF-8 is the sender encoding in Python, when you save a file, it will be saved as UTF-8 by default. So let's just data set here dots to CSV. So simple. Then choose file here. This file, you can say, yeah, this CSV. Export here. Okay. And here, before the CSV, let's say it's a UTF-8.csv. And as you see, it worked. Thank you so much for joining me today. If you like this video, give us a thumbs up. In this video, we have learned about character encodings. In the next video, inshallah, we will see inconsistent data entries. So see you in the next video.